Why do some fans show up for baseball games while others stay home? With just a few variables, like day, rivalry status, and the last game result, we can build a surprisingly accurate model of fan behavior. Let me show you how CHAID turns raw data into real insight. We built a database of 1,000 games with variables like day of the week, rivalry status, weather, and team performance to find out. Out of this data, we built a CHAID decision tree to predict whether a fan attends a baseball game based on these features. Let's walk through how to read the tree and what each part means. CHAID stands for chi-squared automatic interaction detector. It works by running a chi-square test to find the best variable to split the data, grouping categories that behave similarly, and repeating this until no statistically significant splits remain. The way we run the model is we go to classify, tree. We're going to put game attendance as our target. And then we're going to use weather, last game result, day, whether the game was a rivalry game, and then time of day in independent variables. We're going to keep the default at CHAID, and we're going to let it fall naturally. Double click on it so we can open it up, get a clear view. So what we're going to find is that each node in the tree shows the predicted outcome, whether the game was attended or skipped, the sample size in that group, 400 for 600 in the first split, for example, the percentage of the total sample that specific node represents, so 40% versus 60%, and the percentage within that node for each outcome. So for example, node 1 shows that during the weekend, 59% attended the game, 42% skipped the game, versus on the weekday, 20% attended the game and 80% skipped the game. What this denotes is this is the highest partial correlation to the target based on all the variables involved, showing the most significant split according to chi-square. The first split is day. Fans behave differently on weekends versus weekdays. Weekend plus a rivalry game suggests very large attendance at 90% versus a non-rivalry game only at 44%. Then you look at the idea of a weekday on a non-rivalry game, we're only at 10%. So you can see the substantial difference between 90% and 10% based on these two factors alone. Time of day and last game result also matter in later branches, as you see here. And if you want a much more full, detailed walkthrough on the interpretation of this decision tree, check out this video here. To measure performance, we look at the confusion matrix. The model correctly predicts 75% of actual attendees and 87% of those that skipped for an overall accuracy rate of 83%. That's excellent for a model using only categorical variables and one that gives us explainable logic at every step. And if you want a much more detailed video of how to walk through all the intricacies of the confusion matrix, check out this video here. So that's how CHAID works. Part predictive model, part decision logic map. Want more demos that break down models in plain English? Follow for more. Fast, visual, and actionable.